In this video, you will learn how to run matrix operations in Octave Matlab. The mathematical rules for matrix operations are given in separate videos, and in this video, I will focus on how to use Octave Matlab. Let's start with matrix addition subtraction, scalar matrix multiplications, and followed by element-wise matrix operations and transpose matrix. Then wrap up with a summary. Consider the same size of matrices A and B. If you want to add matrices A and B, you can use plus sign between A and B in Octave Matlab. Similarly, you can use minus sign between A and B if you want to subtract matrix B from A. Remember, the size of matrices A and B must be the same to add or subtract. Otherwise, it will give you an error message. The resulting matrix size is the same size of matrix A or B. Consider given two matrices A and B. I will show you how to add those matrices and save the result in the new matrix C. First, you need to create the matrices A and B. Then you can type C equals sign followed by A plus B. The resulting matrix C is shown below. The elements in the matrix C are element-wise addition between matrices A and B. What if you want to subtract matrix B from matrix A? Since we already created matrices A and B before, we can simply type C equals sign followed by A minus B. The resulting matrix C is shown below. The elements in matrix C are element-wise subtraction between matrices A and B. What if you want to add two matrices A and B having different sizes? For example, 2 by 2 matrix plus 3 by 3 matrix. Since I have the existing 3 by 3 matrix A, I will clear variable A, then create a new 2 by 2 matrix A. Unless you clear the existing matrix A, it will remain as 3 by 3 matrix. When you add two matrices, you can see the error message saying that the matrix size does not match for matrix addition. For scalar multiplication, consider scalar quantity lambda and matrix A. The scalar multiplication is element-wise multiplication of scalar quantity lambda. You can simply use lambda star sign and matrix A. Consider given 2 by 2 matrix A. 2 by A means that it needs to double all the elements in the matrix A using scalar multiplication. To calculate 2A, you can use C equal 2 star followed by A. You can see the doubled elements in the matrix A. For matrix multiplication, consider matrices A and B. Similarly, you can use star sign between two matrices. However, in order to multiply two matrices, the column size of matrix A must be the same as the row size of matrix B. Otherwise, it will give you an error message. Let me elaborate how to check the matrix multiplication conformity. Consider M by M matrix A and P by Q matrix B. To check the conformity, you can lay out four numbers for sizes of matrices A and B in series. In this case, you have N, M, and P, and Q. If the matrices A and B are conformable, M must be the same as P. The size of resulting matrix is N by Q. Consider two matrices A and B. What is a matrix multiplication of A and B? To calculate the matrix multiplication, you need to create matrices A and B. Then multiply them by using star sign. You can see the result below. Question comes, what about B times A? Also, is B the same as AB? Let's find out. BA can be calculated using B star sign A. The result different from the one for A times B as expected, so the answer is no. What if we have 2 by 2 matrix A and 2 by 3 matrix B and want to calculate matrix multiplication? First of all, is it possible to calculate? The answer is yes. The column size of matrix A is 2, which is the same as the row size of matrix B. In Octave Matlab, we create matrix B and calculate the matrix multiplication as C equal to A star sign B. What about given matrices A and B? Since the column size of A is different from the row size of B, you cannot multiply. Let's see what happens in the command window. As expected, it ends up with error, saying inner matrix dimensions must be agreed. Consider 1×3 row vector A, and we would like to square all the elements to create 1×3 row vector C. To do this, you may quickly come up with C equal A squared. However, it shows an error message, since the inner matrix dimension does not match. Column size of the first matrix A is 3, and the row size of the second matrix A is 1, which is different. The same thing happens when you use A times A. What you wanted is to do the element-wise squared in all the elements of A. For the element-wise operation, you can use period before your operator. You can also use period for division and exponentiation. So you can use A period caret 2 to achieve what you need. Also, you can use period for the star sign. We have two row vectors A and B, and would like to create a row vector C by having element by element division. For example, the first element 1/2 comes from 1 divided by 2, and the second element -1 comes from -1 divided by 1, and the third one is related to 2 divided by -1. Again, you can use period for element by element division. Consider a row vector A. If you want to transpose vector A by swapping the row and column indices, you can use the single quotation mark at the end. You first create the vector A, and then you can transpose it using single quotation mark at the end later. In summary, we talked about matrix addition, subtraction, scalar, matrix multiplications, and followed by element-wise matrix operation and transpose matrix. Thanks for watching this video, and please subscribe my channel if you haven't done it yet. Thumbs up if you enjoyed. Please feel free to share your thoughts in the comment section below. See you next time.